Good day, Math fam. Welcome to another video. Let's do Euclidean geometry. So the problem reads as follows. In the diagram below, O is the center of the circle. So this point here is the center of the circle. A and B lie on the circumference. These 2 points here lie on the circumference of the circle. And AP is equals to BP. That's a given. So the first question wants us to prove that AT is equals to BT. That is, this line segment here is equals to that line segment. So let's work with corresponding angles and congruency of triangles to find some of the unknowns in the given diagram. So our first focus will be on the bigger triangles. That is triangle OAP and triangle OBP. Notice that in triangle OAP and OBP, AP and BP are line segments that are equal in length, so that's worth noting. So that's a pair of corresponding sides. Also notice that this line segment OP is common for both triangles. So for both triangles, that line segment is equal. So we can say that OP is equals to PO. That line segment is shared by both triangles, so it's common for both. So there we have another pair of corresponding sides. Notice that both triangles OAP and OBP have radii, so those two line segments are equal. So we can also note that AO is equals to OB because of radii. So that's another pair of corresponding sides. So through the condition side, 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 we can say that these two triangles are without a doubt congruent. And because of congruency, the angles across the equal sides, O1 is across this side and O2 is across that side. We can say that therefore angle O1 is equals to angle O2. So let's focus our attention to the smaller triangles, corresponding smaller triangles, that is OAT and OBT, so that we can try and prove congruency in those triangles in order for us to show that these two sides are equal in length. So notice that in triangle OAT and OTB, this side here, OT, is equally long for both triangles, so that's a common side. So that's worth noting. We can say that OT is equals to TO. It's common. So we have a pair of corresponding sides. Also, angle O1 is equals to O2 because we saw with congruency of the bigger triangles. So now we have a pair of corresponding angles. And of course, side AO and side OB are equal in length because of radii, so it's worth noting that as well. So that's another pair of corresponding sides. So through the condition side, angle, side, we can say that triangle OAT and triangle OBT are congruent. And because of congruency between those two triangles, the sides across angles that are equal in size are also equal in length. Therefore, it implies that AT is equals to OB. So the second part of the question wants us to prove that the angle OTA is 90 degrees. That is, this angle OTA is 90 degrees. Notice that OA and OP are adjacent and equal in size because of radii. AP is equals to BP, and those two corresponding sides are adjacent. So essentially what we're dealing with here is a kite, and we know that the long diagonal bisects the short diagonal at 90 degrees. So because of properties of a kite, we can say that the long diagonal bisects the short diagonal at 90 degrees. So OTA is equals to 90 degrees. Properties of a kite. And this is because quadrilateral OAB OABP is a kite because pairs of adjacent sides are equal. Thank you for watching, guys.